Good job. That was probably the best one so far. Nice delivery, good timing, well rehearsed, and you covered a lot of good things. I'm really glad to see that your minimum success criteria doesn't involve leaving one of the humans behind, as it has in every previous one of these. But as the mission integration team, your job is, and the challenge before you is of course to reconcile the trades between the different teams. Can you tell me about how you manage that with respect to your risk and your mitigation plans, and how you reconcile the allocation of budget with respect to the requests from the other teams?
Thank you. Well, what we had to do is, especially with budget, we gathered, first of all, before designing our preliminary budget plans, we gathered a list of the different components that each team needed. And so they gave us a cost breakdown as well as a mass, volume, and power breakdown of the different systems that they needed that were preliminary. And we took those numbers and we gave a rough estimate of what was needed for each team. These did change because they added more components or subtracted some components. But mostly what happened, it was a matter of communicating to us what they needed and we communicating to them what was able to be lifted or what was able to be allocated in the budget cost. And so what we really needed and what we really focused on was the actual breakdown of every single component in their budget as those four: cost, volume, power, and mass. And with that, we could really see what was necessary and vital and what systems could be in the mission, but were not extremely vital to the success of the mission.
Thank you. Good answer.
I was just going to add to that, one of our backup slides is a breakdown of our radiation systems, which will be discussed further in depth by the other teams.
I'd like to echo Dr. Jordan. You guys did an excellent job, and to the point, your slides are real good and clear and concise. I have a question on your mission success. You look like you picked less than 30%. And I was curious how you calculated that, what your thought pattern was, or how you went through to arrive at that number.
Well, first we tried to put hard numbers on almost every critical element in our system, but we really couldn't find any information on that because we had time constraints and such. So we just we estimated that it would be a below 30%. Because we looked at previous missions and things like that. And also we have, like I said in the presentation, we have triple redundancy on a lot of our systems. So.
And one thing that I wanted to add is that we looked at the TRLs of all the different components of the three teams, and most of those numbers were high. And with that, we gathered that most of the systems will be pretty productive and won't fail. There are some systems that had low TRL numbers, and that's why we couldn't come up with an exact percentage of loss of mission. But because we had so many high numbers, we kind of calculated that it wouldn't be higher than 30%.
Okay, thank you. Just have a couple of quick questions. On your mission success, you mentioned triple redundancy a couple of times. Could you say if it's like or non-like redundancy? In other words, are you using three of the same things in parallel, or are you using something that's something different to ensure if you have a systematic problem, it won't cause you problems across all three parallel systems?
I do not know the answer to that question. My guess would be yes, but I don't know.
Thanks. And then the other question, real quick, and I'll pass on the mic, was on your volume constraints, since you were so tight on volume. What set your volume constraint? Was that launch, or was it Mars entry to satellite?
Shrouds that we picked were 420 cubic meters, and all the components when we compiled them were 418 cubic meters.
I thought it was a very comprehensive presentation. Thank you. I have one question about, in addition to returning a cubic metric ton of material to Earth, did you consider scientific experiments while on Mars?
We did, and I believe that's something that the science and surface operations team will discuss later in their presentation.
Okay, good job also. Two quick questions. One back on mission success. Again, you define loss of mission, right? But you give criteria for success. What is your criteria for loss of mission? Is it
Our criteria for loss of mission would be anything that does not, it does not achieve minimum success.
so if one person died during the mission or was hurt by one of the machines there, would that be considered a loss of mission, or would it be the crew never arrived?
We thought about this a lot, and we decided that almost all of the scenarios we could think of where someone was grievously injured or died would be a failure of the mission.
So, second question, for crew selection. You know, robots are becoming more human-like every day, to the point of being scary. Did you consider a humanoid type robot as a potential crew member?
I believe surface, I'm not fully qualified for this answer. I'm not sure if surface operations considered adding a robotic crew member aboard transit, but to my knowledge, no, but it would be good to double check that.